Jai Hind to all. Myself, Dr. Yogendran Prajapati. Today I am going to teach very interesting topic, that is computer architecture and organization, and the topic is about the instruction cycle. Before the discussion about the instruction cycle, first we understand what is the instruction. Then what is the different cycle of the instruction by which any instruction are executed into a CPU. Now, what is the instruction? Instruction, we can say that is a set of data, a sequence of the data by which a computer can perform a specific task is known as the instruction. Set of data, and all data are written in a specific manner. Specific manner or in a specific order, so that we can say that a set of data is known as the instruction. Another example of the instruction, an instruction is also known as the a program. Instruction is also known as the program or a set of program, same thing, by which we can execute into a CPU to perform the specific task. So that is the another definition of the instruction. And the third definition, that is the first, that is the second, and that is the third. The third one of the about the instruction, instruction is known as the set of signal. Set of signal we can also known as the set of instruction, by which the same things, a specific task has been performed. A specific task, with the help of the instruction, a specific task has been performed by the computers. It means a computer system can perform n number of the tasks. How many tasks? That is n number of tasks. It means an instruction are designed in computer system. If have the n tasks, then for every task one instruction are designed. It means total n number of the instruction are designed for the basic computer architecture. Then to study, to read, to memorize all an instruction, that is very tough work. Then these instructions are classified basically into the three part. First one, an instruction which is come from the memory, that is known as the memory reference. This is the first type of the instruction, that is known as the memory reference. It means instructions are stored into the memory, and when computer can perform any kind of the tasks, then from memory data or instruction are transferred into the CPU. Then such type of instruction is known as the memory reference. We are taking the very simple example. For example, move A. Now, move is a instruction. It can transfer the data A from the another location. If this move are stored into memory, then we can say that this move is known as the memory reference instruction. Okay. Now, the second type of the instruction is known as the register reference. All the instructions are executed into a CPU in three different techniques. The first one is the memory reference, second one is the register reference. Similarly, that instruction if execute from register into a CPU, then that instruction is known as the register reference. Move A, if these register contain these instruction contain into a register, then we can say that this register, this instruction is known as the register reference. And the third one, that is very simple, that is IO reference. In IO reference, instruction are execute from input and output device. Same examples, and we take the another example, load X, LDA X, that is the instruction. If this instruction are insert from IO device, then we can say that this instruction is known as the IO reference. So, these are the basic idea about the instruction and a different type of the instruction and how these instructions are classified into these three portions. Now, we move on the topic, that is instruction cycles. The instruction cycle are basically have n number of time scale. When any instruction execute into a CPU, then your first register, that is known as the PC, are active, and he pick the address and transfer into a address register. Now, place the content of PC by the bus selection, and at that time these selection lines value are this, and during the time cycle, the first step of the instruction cycle, simply program counter hold the address of the next instruction, hold the address and is transfer into the address register, and is take, that is the T0 time cycles. Now, that is the first steps. Now, the second step is perform the time cycle 2. Address of the instruction are transfer into a address register. Then memory of address, suppose that is the PC, this is also a register, it pick the some address 10101. Now, this is your memory, in memory have the n number of this, suppose here is the 1000101. Now, the first PC pick this address, and in address, that is the memory of the AR, that is the memory of the AR. Here this some data are picked. Then this address PC transfer into the address register on the first step. Now, second step, the memory of the address are transfer into the another register. Memory of this, in this value, this data are transfer into the one special register, that is the IR. In IR, we transfer the memory of the address register, and the role of the PC is finished. And what is the behavior of the PC? PC is equal to PC plus 1 when it transfer the address of the instruction into a address register. Then address register pick the address, memory of the address, and that data are transferred into instruction register. Now, this process take time T1 time cycles, and that is the very important. Here is the selection line S2, S1 and S3, and here is selection line are enabled, that is the 111. It means the value of this data are transferred into a instruction register. Now the transfer the content of using bus in by the IR only are enabled, that is the LB input into the instruction register, and that is very after transferring the register the PC increase, that is PC is equal to PC plus 1. Now this whole process T1 and T2 process is known as the first step of the instruction cycle, that is known as the fetching of the instruction. Instruction cycle are classified into the three part. The first part is known as the fetching of the instruction, and the fetching of the instruction are classified into the two time cycles, that is T0 and T2. And what is the fetching of the instruction? Instruction are transferred from memory to instruction register, that is the fetching of the instruction. Now the first step has been complete. Now we move on the second step of the instruction cycle. After fetching, we move on that is the second step. Our second step is known as the decoding of the instruction. Decoding of the instruction. Now the decoding of the instruction is also very interesting story, how the each instruction are decoded on the instruction register. Now this process, that is known as the decode, and decode this operation performed during the time cycle T2. In T1 time cycles PC are active. In T1 time cycles fetching of the instruction. In T0 PC are active. And now story of the T2. Now the size of the IR register is 16 bit, that is the IR, and these 16 bit are classified into the three part. 12 to 14 bit is known as the opcode of the instruction, that is also known as it is a 3 bit, and it has the 3 bit, it means it generate total 8 number of the possible data, that is known as the D0 to D7. This one is decoding. Instruction decoding, that is it takes time for the execution, we later on discussion for the decoding. First we discussion about the decoding of the instruction. Now the starting bit 0 to 11 bit, that is known as the address of the instruction, and the second bit is known as the opcode of the instruction. Now that is the decoding 0 to 12 bit, and that is the 0 to 11 bit is known as the here address of the instruction, here the opcode of the instruction, that is known as the opcode of the instruction, that is known as the 12 to 14 bit. 0 to 11 bit, that is the address of the instruction. And now this one, that is the very important, that is known as the mode of the instruction, or that is the 1 bit, that is I. Now from here we decide the instruction are execute register reference, instruction are execute with memory reference. Memory reference is also a two type, direct memory and indirect memory, and the instruction are execute with register memory input output reference. Now if D is 0, then memory reference, if I is equal to 1, then it is known as the indirect reference. If I is equal to 0, then direct reference. And now this is the time cycle, that is very easy. For this process time cycle 3, for this process is time cycle 3, and that is another. It means for D is equal to 0, instruction are execute into a memory reference. What is the value of the D? Let's check on. Now 0 0 0 0 0 1, and dot 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 111. It means for this value data are execute with memory reference. For this value data are execute for memory reference, and only for this value instruction or data are the same things. Instruction are execute in register reference or IO reference. Now let's take time cycles T4, T5, T3, because T2 here, T3 is here, and another 3 time cycles are stored. Or now we discuss about the next figure, that is the main important figure, this one, by which we can identify about the instruction cycle. Let's start. Now in starting, that is the sequence counter is starting 0 because no instruction are executed into a CPU. Now the first step, your PC are active and is transfer the address into a address register. AR stand for the address register. Now that process is T0. Now in second step, simple, the memory of the address register are transferred into the IR register. Now this is the IR register. IR register, that is the memory of the address register, and that is the behavior of the PC. PC is equal to PC plus 1. Now this process is mainly known as the fetching of the instruction. Now this process is known as the decode of instruction, and this process is known as the execute of instruction. Now decode, the instruction are classified into the 3 part: address part, opcode part, and the baud part. That is the 0, 11, 12 to 14 and 15 bit. These 16 bit are classified here, classified 12 to IR, that is the opcode, 0 to 11, that is the address part, and now this is the 15 is known as the mode part of the instruction. Now we check the value of D, or we check the value of I, or that is the D. If D is equal to 0, how many combination of the D? That is 0, 0, 0, 0, 1, 0, 0, 1, 0, and dot 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 1, 1, 1. Now this is 3 bit 0, 0, 0, and these are the possible combination of the D. And when D is equal to 0, when D is equal to 0, and now these all value represent D is equal to 0, or this single value represent D is equal to 1. If D is equal to 1, then instruction are execute into a memory reference. If D is equal to 1, then instruction are execute either register reference or input output reference. Now when we check D, then we check I. If I is equal to 1, then instruction are execute IO reference, and SC is equal to 0. It means the first instruction are execute. If D is equal to 1, I is equal to 1, then instruction are execute in the input output reference. Move on. If D is equal to 1 and I is equal to 0, then instruction are execute into the register reference. What is the condition? D is equal to 0, I is equal to, D is equal to 1 and I is equal to 0. Now move on in the memory reference. There is a 2 type of execution in the memory reference. The first one is the direct reference and the second one is the indirect reference. If D is equal to 0, then check I, again check I. If I is equal to 1, then indirect reference. Directly instruction are not execute when it need the some kind of the address. It means we check another address, then instruction are execute. That is the indirect. And when D is equal to 0, I is equal to 0, then nothing, and instruction are execute in direct reference, and these T3, 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 and execution of the process take the single time, and from here instruction are executed. Now this one is known as the execution of the instruction, this one known as the decoding of the instruction, and now this one is known as the fetching of the instruction. Now these are the three main point by which any instruction are execute into a CPU. We taking the some example for understanding about the how the instruction are execute with examples. We take the register reference. Now that is very simple. In starting, that is the SC is equal to 0. Now in starting, accumulator contain the 0 and E bit is 0. Now here accumulator can be that is known as the complement of the accumulator. Now here the complement of the E, here the calculate the right bit. Now for this operation we calculating the right bit. For this operation we calculate the left bit. For this operation we can perform these different type of the instruction are execute in different format. Now these are instruction are execute in basically three types. These are the very simple example. Now in a very process, just you can say that PC is equal to PC plus 1, PC is equal to PC plus 1. So this is the behavior of the PC. After execution, PC must be increased, that is PC is equal to PC plus 1. Now very important topic we meet in the next lecture of the computer architecture, that is we cover in the in pipelining or the how the control unit are designing in the upcoming lectures. Thank you all. Thank you.